Welcome back, everyone. We're on day 33 out of 50 now of the series, and today we'll be working on more SAT math, specifically problem solving and data analysis questions. We're going to start off with this problem over here. We have for the finale of a TV show, viewers could use either social media or a text message to vote for their favorite of two contestants. The contestant receiving more than 50% of the vote won. An estimated 10% of the viewers voted, and 30% of the votes were cast on social media. Contestant 2 earned 70% of votes cast using social media, and 40% of the votes cast using text message. Based on the information, which of the following is an accurate conclusion? Before you freak out about the numbers here, just focus on eliminating answer choices, especially for word problems. For answer A, if all viewers had voted, contestant 2 would have won. So we can't assume what the other 90% of viewers are going to vote. So this will be incorrect. So option B, viewers voting by social media were likely to be younger than viewers voting by text message. We have no data on the age of the voters, therefore we can't assume anything about how this relates to what they voted through. Option C, if all viewers who voted had voted by social media instead of by text message, contestant 2 would have won. Well, if we look here, we can't assume, again, that changing platform of voting is going to affect the decision that the user makes, the voter makes. There's no evidence of a correlation between the two, so this again has no substantial evidence to be correct. And this leaves us with option D, which is viewers voting by social media were more likely to prefer contestant 2 than were viewers voting by text message. And yeah, that pretty much sums up that one. If you're confused about how this is right, it pretty much gives us the evidence. 70% of the votes cast using social media were won by contestant 2. So, yeah. Okay, for this problem, it's a difficult problem. 3, max difficulty. So we have the scatter plot shows the relationship between two variables x and y for data set E. A line of best fit is shown. Data set F is created by multiplying the y coordinate of each data point from data set E by 3.9. Which of the following could be an equation of a line of best fit for data set F? Okay, so we have a line here, and we want to find y equals mx plus b for that line. So b is approximately 12. Now we need to find m. We know m is equal to y2 minus y1 over x2 minus x1, so that means we just have to pick 2 points. We're going to pick the points here, which is 17 and 40, and we're going to pick the points here, 1 and 15. So this will be x2, this will be y2, this will be x1, that will be y1. So we have 40 minus 15 over 17 minus 1 is equal to 25 over 16. Oh, I'm sorry, this is not a 1, it's a 2. So that'll be over 15. Because these go by increments of 2. So be very careful. I just messed up on that, so don't make the same mistake there. So this gives us 5 over 3. And this is approximately equal to like 1.66 repeating. So just keep that in mind. We're multiplying the y coordinate of each data point by 3.9. So if we have our line y equals 1.66 repeating x plus 12. We need to look for an answer choice that is going to have similar numbers when we multiply this whole thing by 3.9. So just for the sake of estimation, we're going to approximate 3.9 and round it up to 4. So we have the y isn't multiplied because this is, well, we can multiply it, but because this is going to be y of e, and we're looking for y of f, data set f, if that makes sense, because this is the line for this data set over here, and this is the new line. So we have 1.66 times 4. Well, I don't really know what that is without a calculator. Even though we have one, we're not going to use it. And plus 48. And 1.66, we are going to use one, I lied. 1.66 times 4 is equal to like 6.64. And we overestimated this, remember, because we rounded it up. So we're looking for around a low 6, high 5 number. So this is good, this is not, this is good, this is not. Now we're looking also for y-intercept, which is around 46, like a little lower than 48. This is good, this is not, and that gives you your answer of A. Obviously, you can multiply by 3.9 since we used our calculator anyway, but the answer choices weren't even close, so safe to say either approach works. Okay, next problem. A park ranger asked a random sample of visitors how far they hiked during their visit. Based on the responses, the estimated mean was found to be 4.5 miles, with an associated margin of error of 0.5 miles. Which of the following is the best conclusion from these data? Okay, A, it is likely that all visitors hike between 4 and 5 miles. Even though this is convincing to pick, it's not correct because it's using very deterministic language of all visitors, and we don't know that because margin of error does not account for every single output of data. It is likely that most visitors hiked exactly 4.5 miles. Well, once again, it's likely that most visitors hike between 4 and 5 miles, not 4.5 miles exactly. It is not possible that any visitor hike less than 3 miles. It is possible. Remember what I said? The margin of error doesn't say it has to be specifically within 4 and 5 miles. It's just likely that it is within 4 and 5 miles. Okay, and that leaves us with that answer choice B. It is plausible that the mean distance hiked for all visitors is between 4 and 5 miles. Mean distance hiked for all visitors. So it's saying the mean is between 4 and 5. For each individual. So this is different from answer choice A because it says they hiked between 4 and 5 miles, and this is saying the mean is between 4 and 5 miles. Okay, next question. In the given scatter plot, a line of best fit for the data is shown. Which of the following is closest to the slope of this line of best fit? So remember, we're finding a slope for the line, not for the points. So we are going to pick points on the line. We can pick this last point right here. So that's going to be 10, and 1. And then we can pick this up here, which is going to be 0 and 8. So remember, you don't have to pick like points like these or like these because it's asking for the slope of the line, not anything else. Okay, so we have our slope that we know is y2 minus y1 over x2 minus x1. We're going to say this is x1, this is y1, this is x2, this is y2. So we have 8 minus 1 over 0 minus 10. This is going to be 7 over negative 10, which is equal to negative 0.7. Look at our answer choices. it is C. Okay, looking at this last problem we're going to do for today of maximum difficulty. We have a data set A that consists of 10 positive integers less than 60. Important information right here. The list shown is 9 of the 10 numbers from data set A, and we have them here. The mean of these 9 integers is 42. If the mean of the data set A is an integer that is greater than 42, what is the value of the largest integer from data set A? So we're looking for the largest integer in the data set, but we don't have one. So we know that this last number is going to be some value, let's say x. So we know that the sum of these are going to be 378 plus x. And we know that the mean is all the numbers divided by how many there are. And we know that this number is going to be greater than 42, because we know the mean of the data A is an integer that is greater than 42. So if it's an integer greater than 42, it could be 1,000 different things, but we're going to start with the next highest one, 43. And there's one more restriction we have to consider. And I'm picking 43 because we know that we have 10 positive integers, as we set up here, less than 60. So we know x is going to be greater than 42, and it's going to be less than 60. We know it's going to be greater than 42 because it has to bring up the mean. The mean is greater than 42, but right now the mean is 42, so we need a larger number to bring up that mean. So that's why we're picking 43 to start. So starting with this, we're going to multiply, we're going to simplify, and we get x is equal to 52. Now we check if this satisfies all the conditions. 52 is between these, and it does give us a value of the mean that is greater than 42 and is an integer. So when you see these questions, don't freak out. Use your intuition, your logic, and it should save you in these type of scenarios. And this is where we're going to end off for today. I hope these problems helped with your studying, and I'll see you on the next episode.